Hello and Assalamualaikum. Firstly, let me introduce myself. My name is Muhammad Izam bin Muhammad Nazif from 214 and my other friends.
Hi, my name is Muhammad Zikri bin Simarudin and I am from 214.
My name is Muhammad Akasha Mukris bin Zainuri. I'm from 214.
Hi, my name is Nur Shafika binti Muhammad Yazid and I'm from 214.
We all from Team 1. So, our topic today for the group discussion is trigonometric functions. So, what is trigonometry? Trigonometry is the study of the properties of triangles and the trigonometric function to be used for the various applications. Trigonometry studies the relationship in mathematics that involves length, height, and angle of various triangles. Trigonometry is found across geometry. It is basically considered as the computational component of geometry. Trigonometry is about study of the angle and the dimensions of the triangles, where one of the internal angle is around 90 degrees. Today, trigonometry plays an important role in a wide variety of careers, including engineering, design and architecture and other fields.
So first, I would like to define the trigonometry in navigation. Navigation is the process to accurately determine one's position and planning a route for the movement of a craft or vehicle from one place to another. Navigation also refers to the specialized knowledge used by navigators to perform navigational tasks. Navigational techniques involve locating positions compared to known location and patterns, as well as determining the distance between places. Modern navigation rely on the satellites to determine positions and to travel by sea and by air. So next, what are bearings? In marine navigation, a bearing is the direction one object is from another object, usually the direction of an object from one's own vessel. In aircraft navigation, a bearing is the actual compass direction of the forward course of the aircraft. In land navigation, a bearing is the angle between a line connecting two points. Bearings is usually measured in degrees. So next, let me give some of question to answer. So we have the question that given the ship and the lighthouse. So we have the height of the lighthouse is 60 meter. That is AB, and we want to find BC. And the given the angle of depression is theta equal to 20 degree. So what is the distance between ship from the lighthouse? So we have all the information that we can conclude that we need to use the tan, because the tan is the opposite over adjacent. So we just put it on the formula. So we get tan 20 degree equal to 60 over BC. So after we calculate all, we get the answer. The distance between ship and the lighthouse is 164.8342 meter. So that's all from me. Thank you.
Let's say I have a long pole here and need to measure its height. Now, for the sake of simplicity, I'm going to assume that I'm actually standing inside the hole of shot and the ground is at my eyes level. You will soon realize why this is important. So the ground is at my eyes level, so the base of the pole starts at my eyes level and the pole goes on further up from there. Now we need to measure the height of this pole. How do we do that? Do we see a triangle anywhere here? Actually, we do see one side right. The pole looks like a nice straight line, which is why I picked the pole instead of the mount. We need two more lines, right? Or two more sides from the triangle. If you join the pole to my eyes, that could be the second side of the triangle. This is nothing but the distance on the ground, how far away I am from the pole. Now, imagine me looking up at the pole and imagine the ray of light that is touching the top end of the pole and reaching my eyes. If you were to imagine that ray of light and you draw a line for it, call it my line of sight. That could be the third side of the triangle, that could be the hypotenuse or the third side of the triangle. One side, the vertical side of the triangle, is our pole. The horizontal side is the distance between the base of the pole and my eyes. And the third side is my line of sight. Perfect. So we have a triangle here. All we need to do is measure one side of this triangle. How do we go about measuring that side? The horizontal distance, if you see, can very easily be measured, right? I could just start at the base of the pole and walk up to here and measure it. It's a distance on the ground, very simple to measure. So, the distance we can measure.
Let's say we measure it and it's 30 meters. Now the height of the pole, let's say the pole is a height we cannot reach the top. You are not going to do pole climbing, right? If we cannot measure the height of the pole, neither can we measure the distance of the hypotenuse. Because the same logic correct again. You need to reach the top of the pole to able to measure the height part. So it's not going to be practically possible to measure the hypotenuse. If you could, then you would simply use Pythagoras theorem. If you could measure the hypotenuse, you would use Pythagoras theorem to find out the height. But that doesn't work, right? If you could measure the hypotenuse, you could very easily measure the height itself. So we cannot measure. What else can we measure? Now remember, we are talking about trigonometry. Trigonometry is something to do which angle, one angle is anyway, right? Angle triangle, which is why we can apply trigonometry, is this triangle. Can we measure one more angle? Can we measure this angle?
As I look up at this pole, my line of sine, can you measure the angle of my line of sine with respect to the horizontal? Can you measure this angle? Seems difficult, right? Almost impossible. Try looking at object around. Are you ever able to say what is the angle at which you are looking? Not really, right? Instead of the naked eyes, let me take a binocular at my eyes level. Let me fix it to a post, and the post has a protector, right? So I can measure the angle at which my binocular is turning. Now, imagine keeping it at 0 degrees. So I'm looking straight down and I'm going to able to see the base of the pole. I slowly move the binocular up as I see more and more of the pole, and I keeping moving it up until I finally see the top of the pole. Stop it there. I stop it there. Now, if I measure the angle at which the binocular is with respect to the ground, I can easily measure the angle. I already had a protector fixed here, right? So, I can easily measure the angle. So, this angle we now know, right?
Let's say it's 60 degrees. So now we know the angle is 60 degrees. And the base, this distance, this length is 30 meters. Now in this triangle, can we very easily measure the height? We can very easily measure the height. It's right. Angle triangle, correct, is a right angle triangle. So one side is going to be with respect to this angle. If angle was angle theta with respect to this angle, the base is going to be the adjacent side, and the height of the pole is to be the opposite side.
What is the trigonometric ratio that relates the adjacent side to the opposite side? The answer is tan theta or cot theta. So, let's say we take tan theta. What is tan theta? Tan theta equal opposite side over adjacent side. In this case, we measure our theta to be 16 degrees. So, you will get tan of 16 is the height of the pole. Let's say is h. H by this distance, we measure it as 13 meters. So, it h by 30 meters. Tan 30 is h by 30 meters, so h will be 30 into 16 degree. Tan 60 degree, you know, is root 3. So, the height of the pole is 30 root 3 meters. And we have our answer.
Last but not least, for the conclusions, we realize that trigonometry can be used in many areas such as astronomy, navigation, and architecture. They can aid in calculating many things. They can also be used in car desks and benches. Without really climbing a tree, You can find the head easily with trigonometry. They can be solved by the use in real-life application and is very useful for most architects and astronomers. We can conclude that without trigonometry, life will be much more difficult without going through the troubles. You can easily find something, so we think that it was a good invention by Archimedes, and thanks to this, many architects need not to go through the trouble to calculate things. So, it is really helps in real life application and not only in our tests and exam.